Okay. 2006, we're going to do 2A, 2B, and then we'll get to 3C. All right, 2A and 2B. It is weird that they crossed that. That's meant to be still in the syllabus. Let f of x equal to inverse sine x plus 5. State the domain and range of this function. You can obviously, because you guys know this is from the HSC, you can write 2006 HSC, write question 2A. So as you're studying for it, you can always just go back as well. All right. Inverse sine. What's the first thing I would pretty much say that you need to know? Before that, I think, the actual graph. The actual graph of the original one. Because if you can memorize the original graph, then you pretty much know your domain and range from that, right? So that's -1 to 1, and then what? Negative pi on 2 to pi on 2. And then, of course, your range, you can see that it's monic already. Because it's monic, your range is not going to change. It's still going to be from negative pi on 2 to y to pi on 2. We agree with that? And obviously, your domain, what do? Replace in the as the x. So replace the x as your x plus 5. So it's usually -1 to 1. But you would say now it's -1 to x plus 5 to 1. Subtract 5 from both sides. The answer we're looking for is x is between -6 and 4. -4. Any questions? You know that's going to come up in your exam. Look how many marks it's worth. 6 marks. That's just how extension works. I think from the Thursday class, what the feeling I got was that they were actually better in extension 1 than they were in advanced. So if that's a feeling that you also tend to have, the reason why that is, you can't forget extension 1 is a 1-unit course. There's a lot less content, which is why I push a lot of you to actually do extension 1 from U10. I knew it will be less content. Whereas in advance is a lot. Find the gradient of the graph at the point where x equals -5. Gradient, what are we going to do? You can't. Hold on. Just to find gradient, what do you usually have to do? That's to find the equation of a line. Yeah? That's to find the equation, which is usually linked with the gradient. How do I just find the gradient? Gradient of any graph.
Differentiate it.
Differentiate it. So the gradient would be the derivatives. Now, we haven't done derivative of inverse sine. That's going to become year 12. So we can't do double line. But at least you now know what year 12 is going to be like. See? Same stuff. Just find the gradient, which is differentiate. You're just going to learn how to differentiate this. It's actually very easy. For those who have seen this because of the Monday class, the answer would be something like this. But that's it. But you're not interested in that for now. And then you'll just have in -5. And technically the answer is 1. The gradient is just 1. So very straightforward stuff. We're interested in sketching the graph that will be asked in our exams. Obviously the graph is exactly right there. Except this is now -4. This is now -6. The center is now what? -5. True? And then of course you'll have your negative pi on 2 and pi on 2. A lot of students get stuck on this because they're like, but isn't that usually 0? Well, yes, but didn't I just label that as -5? So my 0 function is somewhere here. So without me actually, drawing it at 0 and then moving it to the left, Can you see how I cheated there? I just draw it as you would normally do it, and then I know where the zero function is. Very simple. Any questions? No? All right. Any questions? No? Emily, all good? Okay, the next one looks familiar, doesn't it? It's what we've been doing with our binomial expansions and stuff like that. So let's have a look. And again, I'm going to say this one last time. Remember, in extension 1, whatever you learn is tested. It's not like advanced, where you learn everything because it's generic, then you get tested on bits and pieces. So as you're seeing, technically this question, this could have been in your textbooks, let's say. Well, that's pretty much what gets asked. This is literally what we were doing last week. And it's what is asked. So it doesn't actually deviate away from what you get taught. All right, by applying the binomial theorem to 1 plus x to the n and differentiating, show this. Okay, it's telling you what to do. So 1 plus x to the n. What's the expansion to 1 plus x to the n? N choose 0 plus
1 to the power of
n choose 1 x to the power of 1 now plus n choose 2 x to the power of 2 plus n choose 3 x to the power of 3 plus n choose n x to the n. Anyone's still not able to get this out if you aren't, as I just said, it will be asked directly in your exam. So why are you willing to walk into your exam and sacrifice these marks? You know this will be asked exactly like that, you might as well memorize it. And it's not that hard. N choose 0, and then 1, and then plus n choose 1, you increase the x by 1, 1. N choose 2, you're going to increase the x by 2, 2, 3, 4, and so on. Any questions about that line? It says, there it is, we applied the binomial theorem, and differentiate this. So what's the derivative of 1 plus x to the n? What would the derivative of this be? Don't overthink it.
N minus 1, 1 plus, no, n to the power of n bracket 1 plus x, n minus 1, right?
Look at this. Look what you've written. Look what you were required to show. See? So the answer is always going to be there. That's what I was trying to tell you guys last week. Like, look at it. You go, it's a skill you have to eventually learn. By year 12, you'll master it. But if you can learn it now, like maybe for next term, because it'll happen again, it's just going to make your first year 12 exams look good as well. So what do I have? You have this. What do I need? And then you can tell right there. You've differentiate. There it is. The answer's in front of you. Bring the n down. Subtract 1. What's the derivative of n choose 0? What's the derivative of n? Well, what is n choose 0? Can someone tell me? Okay, variable or constant?
1.
Yep, it's 1 specifically. That's constant.
Yeah, so it's 0.
It's just 0, right? Do you guys see an n choose 0 here? What happened to it? Well, it disappeared because what do you do when you differentiate a constant? Go on. What's the derivative of n choose 1x? What do you usually do when you're differentiating something multiplied by x? Isn't it just that something? So what's the derivative of 3x, 4x, 5x, 10x, 20x? Any x. It's just that anything. So it's just n choose 1. There it is, n choose 1.
Oh, plus 2.
Plus, how do I differentiate n choose 2x squared? Well, what do you do with x squared? You bring the 2 down, that's it. N choose 2, you take away 1 from the power, x, plus 3. N choose 3, x squared, plus, dot, 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 plus. You bring the n down, and observe. Do I have it? That's just trying to say it happens at any r value, which it's fine. And there's your n. Done. 1 mark. I'll pause. Any questions?
So are all binomial questions in a look like that?
I could make it harder. I could do this to it. What would you have to do this time? X times 1 plus x to the n. What do you have to do when you're differentiating that? X times 1 plus x to the n. That's product rule. So you can do things like that. That makes it, that's probably the hardest ones. And that's it. But otherwise the style of question is exactly the same. All right, hence deduce. Look at it, look at it. Look. And what do we reckon? What's happened? Compare. What's happened? Keep looking, keep looking. Emily, you think you can see it? Don't say no. You want us to take a guess? Wait, look at this, look at this, look at this, look at this, and look at that, and look at that, and look at that. But that's, aren't they the same right now?
Is x a 2?
X is a 2. So the only difference is, can you see you got 1 plus x here? You don't have an x anywhere here. If x was 2, look at this. This is 2 to the n minus 1. Otherwise, this is n choose n, n choose n, x to the n minus 1. If I just replace x for 2, it all works out. And that's it. Done. So the idea is, what I've got to keep reminding you guys, hey, if you couldn't do I, do not lose your marks for double I. The answer's in front of you. All you had to write was x is 2. X equals to 2. I think you guys can see now. You get n. 1 plus 2 is 3. And the reason why they missed, can you see how they missed this one here? 2 times 2 is 4. They missed that. The reason why they missed that is because a lot of students would usually pick it up from the second one. So they missed out on purpose. But the clue is, look at this here. X, 2, x, 2. 1 plus x, 3. So it's 1 plus 2. Alright, you're done. N choose 1 plus dot 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 plus r, n choose r, 2, r minus 1 if you wanted to include that one. N choose n, 2 to the n minus 1. Actually, I think the hardest ones are not even that product rule one. The hardest ones is when you end up with a result like this, and you have to use index laws to simplify them. So let's just say you're done, but like, you know, that one is 3 to the n minus 1. And then what can you do to 3n minus 1? You could break that up to n, 3n on 3. So what they could have said is prove, instead of it saying this, they could have said do this. And a lot of students go, I don't know, I can't do that, I don't get what it's doing, I don't understand. But in reality, it's exactly the same, it's just using index laws. So to me, I usually say, don't change your math. When you change your math, everything goes wrong. So don't change it, it should be fine. But anyways, that would be the hardest ones. Okay, any questions before I move on to the next one? So we can cross off 2A, 2B. Let's look at 3C and 3D. So 3C, 3D as a replacement. 3C. 3C. All right, probability. Sophie has 5 colored blocks, 1 red, 1 blue, 1 green, 1 yellow, 1 white. She stacks 2, 3, 4 or 5 blocks on top of one another to form a vertical tower. How many different towers are there that she could form that are 3 blocks high? Okay, just take your time. So again, does anyone actually know of a way they would start this? Start. What would be my way to start this?
Draw a diagram.
He just said it. Draw a diagram. You got to learn what your starting point is. When you're trying to change it for a question, Already your brain's gone into a different track. So I would draw a diagram. It wants it to be 3 blocks high. So 1, 2, 3. All right. How many blocks do I have? So how many can go here? How many can go in the first position? 5. And then how many will you have left in the second position? Come on. That's it. That's your answer. But if you don't start like that, you probably won't get it out. Which makes sense. It could be red, green, blue. It could be red, blue, green. It could be red, yellow, white, red, white, yellow, blah, blah, blah. You get the idea. So this, you know the ones you guys seen? This is a 5-letter word. Make a 3-letter word. This is exactly the same thing. 5 times 4 times 3. That's it. Which is 2060. Anyone have any issues with I? I like your starting point. Always draw diagrams. Double I. Double I. How many different towers can she form in total? So how many different towers? Well, she can form a 2-letter word or a 2-block tower. 3-letter word, 3-block tower. 4-letter word, 4-block tower. 5-letter word, 5-block towers. Oh, done. And so if once you understand that, again, case 1. Let's just say a 5-block tower, 5 blocks. So essentially 1, 2, 3, 4, 5. What's the answer to that one? 4 blocks.
5 times 4 times 3 times 2.
Which actually still becomes 5 factorial, because times 1 doesn't do nothing. 3 blocks. Well, we just did that. 5, 4, 3. That's 60. And 2 blocks is just 5 and 4, which is 20. Plus, 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 plus. Easy. It was. But at first you got to, what do I do with blocks of tower and stuff? But I like the idea here. I think you guys got to learn that. You got to learn what your starting point is usually for most of your questions. Like for that inverse sine, I said, what's your starting point? If you know it's to draw your diagram, you're usually okay. What's your starting point here? If you know your starting point is to draw your diagram, you should be usually okay. Any questions? Em, what do you reckon? It was okay, wasn't it? But at first, it's like, well, because you're doing textbook questions, you're not doing exams. It's the HSC exam. I can't make it any more. Like it's harder than that, right? It's HSC. So 2003D. Let's have a look at the replacement question. 1, 2, 3. 3D. Question 1, question 2, question 3, C. No, that's not for this year. That's next year. 3B, that's vectors. That's next year. 3D. That's the one. Oh, Novak already knows what's going to happen. The diagram shows the graph of the function y equals f of x. What do we have? Just so we know, this is -3. This is 1. This is 2. And that is 1. And I think that's it. I think you all should know what's going to happen. What are the questions that you think is going to follow this? Just so I know. Probably the reciprocal, maybe an absolute value, maybe squaring it, something like that. Maybe put a negative in front of it. So if you can, again, already predict the question, you shouldn't be afraid of what's about to come up. Let's see. There it is. Find the absolute value of x, reciprocal, and that's it. 2 marks each. All right. Let's do the absolute value of x first. Now, because I don't want to get this, like I really would like to show you guys this in a proper way, I'm just going to copy that and then paste it on this diagram, just so you can see exactly what's happening. Oh, wait, why do they go down only to -1? Because absolute value of x, fair enough, that's okay. All right, what do we do? Who remembers? Absolute value of x.
You reflect the right side of the graph about the y-axis.
Say that again, because you did say it right. I just want to make sure.
You delete the left side of the graph and then reflect the right side over the y-axis.
That's it. all the x positive, wherever x is positive, which is right here, reflect about the y-axis. So we need to see it like this, and that's why I put 1 and 2 here straight away, because you need to go through 1, you need to go through 2, or negative. Oh, is that 2? That should have been 3. Negative 3, and voila. Negative 1, negative 3. Reflect your positive positive x's onto the left-hand side. So the answer is all of it, right? It's the whole thing there.
Is it a sharp point at the y-intercept?
That's a sharp point. Yes, good point. Sharp. It's not like this. It's not like that. It's like this. Sounds good? 2 marks. Again, you know it's going to come in your exam. So it doesn't make sense to me why you would want to go in not getting this as a 4 marks. Reciprocal, paste. Again, other than Anouk, because he seems to know it. What do we do with an absolute value? What do we do with reciprocal functions? At
the point of intersection.
x value, x-intercepts. So asymptotes are intercepts. There it is, there it is, and there it is. Okay, now the only thing I need to remind you of is, please, if this wasn't a 1, let me just highlight it one more time. This wasn't a 1, if it was a 2, you have to show 1 over 2, which is a half. Just keep that in mind. That's probably the only mistake we see year by year. That's it. Everybody else usually get these right. All right, here we go. Sad, happy. Something like that. Goes through 1 still. Why did I drop it lower? Because this was a 2. Right? Imagine this was a 2, so it becomes a half, something like that, and then I come up. 1 over a very small number. Remember, these are smaller than 1. So 1 over a number that's a fraction becomes a very large number. So it'll look like this. I don't know how, but that's fine. We'll just stop it at -4. And then this one here, 1 over small, 1 over is large, 1 over large is small. I think you should know by now these are going to look like kind of hyperbolas. And voila, 2 marks. Remember, this came down from extension 2. They're trying to say it's meant to be okay, it's meant to be easy. Your teachers obviously didn't teach extension 2, a lot of them. So therefore, the way they're doing it is through their textbooks. And the textbooks are doing a very elementary kind of way. That's why a lot of you probably are not doing it this way. Whereas me, I've taught extension 2 for the last 12 years. So I do things very efficiently. Anyways, done? Yeah. All right, cross. Where are we? 3C, 3D we did. We're up to 5. And again, for those who request this booklet, pretty much this is how I want you to study. Just go and knock it off one by one. 4A, 5B, 4A will do. And then I think we're into the 5s. All right, that's it. 4A. Go up. The extension 1 trial was yesterday. I spoke to my extension 1 students. We're good. They found it okay. They found it better than the advanced paper, which again, happens usually. And funny enough, the ones that didn't say it was okay, 2 of them, the only parts they couldn't do were the graphs that we just did. They forgot that because it was year 11. They didn't revise it for year 12. Okay, the cubic polynomial. A cubic polynomial where R, S, and T are real numbers has 3 real zeros. 1, alpha, and negative alpha. And it just says, find the value of R. Okay, again, in polynomials, there were two things you generally did with zeros and roots. There were two things, so two different, completely different things. If you can know those two things, then you pretty much know all the different kind of polynomial questions. So, what was one of the things that you did in polynomials? It can be wrong, don't worry, just what you got to think about.
Sum
What did you
and
do?
product of roots.
Say that again?
Sum and products of roots.
Sum of roots, product of roots, that's the one thing you did.
And
That is
then,
correct.
yeah.
And then the second thing you would have done when I give you zeros and
You would
roots.
have subbed in the zeros.
That's it. That's your two methods. Method one is sum of roots, product of roots. Method two, if you've got zeros, you would sub them in. Sub in roots. There you go. So every question you're going to get in your exam, it's either this guy or this guy. Now, with this one, sub in roots, that's when you also learn polynomial division and remainder theorem, blah, blah, blah. But that's all part of the same concept. You're just going to be subbing in the roots. And then if there's a remainder of 5, you just write equals to 5 instead of equal to 0. It's not going to be subbing in roots, because if I sub in 1, can you see how I'm going to have, like, all my x's are disappearing, but then I'll have r, s, and t. And that's pretty annoying because it's saying to find r. So if I want to find r, s, and t, I've got to somehow find like a simultaneous equation, and then it's just overkill. So sub in roots, maybe not yet. Maybe not yet. Don't like get rid of it altogether. Just not yet. Sum of roots, product of roots, I think it's going to be sum of roots, because if I was to add these two, what's going to happen? They're going to cancel out. So sum of roots, 1 plus alpha plus negative alpha equals minus b on a, which in this case is negative r. And I think you guys can tell straight away. R equals negative 1. Again, I know you guys read that at first and you saw all these letters, pretty much no numbers other than this 1, and you would have just said, I don't know what to do. But you can't do that, you've got to do it the way I just showed you. Narrow it down to the topic, you know it's polynomials. In polynomials, what were the two main things you did? You obviously learned to graph as well, but I think graph you can put that aside, because that's a bit of a different skill. Find the value of s plus t. What do you think I'm going to say to do now? All right, we're stalled.
Maybe sub in roots.
Let's sub in 1. If I sub in 1, what's p of 1 equal to? 1 plus r plus s plus t. What does r equal to? Minus 1. And then what is p of 1? What is p of 1 meant to equal to? You're done. S plus t is equal to 0. Maybe those 2 marks were easier than that 1 mark. See? So don't get rid of the idea altogether. For those who would have done it through sum of roots 2 at a time and product of roots, it would have also worked out. It just would have been maybe 4 or 5 lines longer. That's it. But the method would work. That was easy. Like I said, don't get rid of that idea altogether of subbing roots. It just wasn't good for the first one. Easy, done. Five A, B, C. All right, pretty much 5A, B, C, and we finished off. Is that 2007? Ugh, as if I didn't see that. Oh well, that's probably why. 5A, B, C. All right, 5A, B, C. And that's pretty interesting. In 2006, you can tell they didn't ask any trig functions. In 2008, they didn't ask any trig functions. And then they asked it every other year. But pretty interesting to see, isn't it? What did we say? Question 5A, B, and C. All right. Question 5A. Show that this is a solution of this. That means pretty much do what to it? Differentiate it, and hopefully end up with this result. What's the derivative of an exponential? It is still an exponential. So I won't do that question. I might just revise your, refresh the question for you. If it was e to the 5x, y dash is still e to the 5x. The only extra thing you have to do is differentiate the 5x, which is 5, and that goes in the front. So be careful, it's not drop the power down, take away 1. It's got nothing to do with that. Try that for this question, and then pretty much you're trying to prove this. Let's see if you can get that out. I'll give you a minute. Anybody at home able to get it out? Okay, can someone tell me what they got for y dash? Let's check out y dash. What do you guys have? Anyone?
Mine is 0.7 times 10 e to the power minus 0.7.
Yeah, I like it. Mine is 0.7 times 10 e to the power of negative 0.7 t. This simplifies to negative... Oh, why would you simplify it? Because you know what you're trying to prove. Try, let's see. You guys. All right. Is there anyone able to get this out? Y dash? Yeah? At home? Anyone got it out? Anu? Shania? Did you guys get it out? Or not? You struggled somewhere? So I am wrong. Shania, what do you know what to do with this one here right now?
No, I differentiate it. So
Say that again.
I don't know what to do after I differentiate it, so not after the first step.
Wait, I'm missing that. Say it again.
I don't know what to do after I found y dash.
Okay, so you did get this line, right?
Yeah.
That's funny, isn't it? You look what you have. Look what you need. Look what you have. Look what you need. Look what you have. Look what you need. It's a skill you guys got to learn. Look what you have. One more time. Look at this one. It matches this. That's why I stopped before I went, and expanded 0.7 with 10. I didn't need to do that because it's already given me negative 0.7. Can you guys see? It says y take away 3. Y take away 3 is 10e negative 0.7t. So guess what I'm going to write in my next line? Equals negative 0.7 y take away 3. Exactly. Oh my God. I just had to write the answer down because 10e is y take away 3. 10e, this bit here, is y take away 3. Shania, can you see that now?
Yeah.
Yeah. More exams. So you can get used to that. What do I have? What do I need? And you'll be surprised. The answer's in front of you. Should be. It really should be. It should be in front. Sometimes it's going to be hidden a little bit, but There are ways to find them still. All right, that wasn't too bad for 2 marks. Really, 2 lines. All right, B. Let f of x equal to ln 1 plus ex. Show that f of x has an inverse. When will it have an inverse?
When it passes the horizontal line test.
Yeah, but how are you going to show it in terms of this? I mean, you don't have it graphically, so you don't know how it looks like. It could look like this.
Oh, you show it's increasing or decreasing constantly.
Yes. You show that it's a monotonic increasing or decreasing. Monotonic means always. Always increasing or always decreasing. How do we show that something's always increasing or decreasing? It's through its gradient, right? Because the gradient would not be changing. So how do we differentiate a log? What's the derivative of a log now? Actually, the derivatives of logs in year 11? I think that's part of year 12. From memory, I think question 5b should be 5b functions. I don't know. Has anyone done derivatives of logs at school, actually? Derivatives of logs. Nope. Yeah, I don't know if that's part of your... Anouk, have you done derivatives of logs at school?
No, not at school.
No, then not, leave it. You've done it with me, I know, but if you haven't done it at school, I think that's year 12. Sorry. So we've got to leave that. What's C? Looks like a rates of change. Yep, that's a rates of change question. Probably, maybe in par with difficulty as binomial is. So this one's a bad one. I think you guys probably remember I spent a few weeks on this because it's not going to be good. So I'll give you a few minutes, maybe have a read of it first, see how you would start it. And I think I did this exact question as well. But anyways, take your time, start it, write what you know, maybe what you remember is our starting point. Okay. Can someone tell me the thing that I've highlighted? What does that represent? What does that represent? What's a rate again? What does rate mean? Starts with D.
Velocity.
Velocity. Yeah, but that's a bit too much. Starts with D. No.
Derivative.
Derivative. Differentiate. Rate. Differentiate. Derivatives. So a rate just means it's a derivative already. If it's centimeters cubed per minute, what does K stand for? Centimeters cubed per minute. D what? On D what?
dv over dt.
You guys remember that now? dV, the derivative of the volume with respect to time is K. The question says show dx on dt. Do you guys remember how to start that? What do we do with dx on dt? We write dx on dt equals... Any
dv
ideas?
over dt times dx over dt.
Say that again.
dv over dt times dx over dt.
Oh, you're close. dx over something times something over dt.
Oh no, dv, right? dx
Yeah,
over
it should be dv and dv. because you're using dv here, right? They gave you dv. So dv on dt is k. Nice. Do you have a relationship between x and v? Do you have a relationship, Novak?
Between x and v.
Yep, somewhere. Do you have an equation that's relating x and v's?
Yeah, we do.
Right there.
Yeah.
Go ahead and differentiate it. Go try.
Which one?
This one here.
That one.
Yeah, that's what that would be, right? You'll get dv on dx, not dx on dv, but you'll just flip it. But you got to differentiate it. That's a relationship between v and x, volume and x's.
Okay.
So you guys try that. Start from here and get dv on dx. It's up to you how you want to do it, but make sure you realize something. That's all I can say at this point. All right, so to use dv on dx, it's either product rule or you would have expanded it first. What did you guys do? Product rule, u, v, okay, u dash v plus v dash u. R is just a constant, so you leave it. All right, that's dv on dx. It's all over 3, so I'm just going to put all over 3 like that. Minus pi x squared over 3 over 3. And what do we do now? That's dv on dx. We wanted dx on dv. Now you flip it. And then you hope, as you expand it, you end up with this result. So let's see. dx on dv, flip, so 3 on, 2 pi x r, 2 pi x 3r, sorry, 6 pi x r minus 2 pi x squared minus pi x squared times by k. We agree with that? Minus 2 pi x squared minus pi x squared is minus 3 pi x squared. And I think we can all see we got the answer out. Divide everything by 3. And then it tells you factorize pi x out. We're left with 2r minus x. It wasn't hard. But you guys just, again, you don't know where to start from. I'm trying to tell you, everything's there. I started from that said k. K is dv on dt. From there, I stopped. I write my dx on dt. I write my expansion out. That tells me what I'm looking for. It said I was looking for dx on dv. I asked, do I have a relationship between x and v? If the answer is no, then you got to go find the relationship between x and v. If the answer is yes, then go ahead and differentiate it. And then if it's exactly the same, great. If it's not, you flip it and just do a bit of algebra, really. So have a look one more time. I read the question if you like, one more time. All right. Any questions? Why? No? If that's a weakness? Oh, sorry,
Sam.
go ahead.
Why'd you flip it? Like, what's the reason for flipping it?
The reason for flipping. So this one here, when you're differentiating v, you've got dv on dx. Is that correct? Like when it's y, don't we usually write dy on dx?
Oh, yeah, I see it, I see it.
And then this says dx on dv, so I have to flip it. So I'm not, when I'm at this stage here, I didn't ask you guys, oh, do we have dx on dv? I'm asking, do we have a relationship between x and v? Because that could either be x's in terms of v, or v in terms of x's, which is what this one is. Doesn't matter which order it is, as long as you have that, then you can always just flip it. All right. I was just saying, if you guys feel like this is a weakness, then maybe go back over the videos for rates of change, go through, maybe do 2-3 questions on rates of change, and believe me, the technique will come back to you. There's always the same thing. Always one's going to be given, then you've got to split this up, then that tells you what you're looking for, differentiate, sub it in, and you should be good to go.
Sam,
Yep.
also, you forgot the x in your final answer.
I forgot to, yes, of course, factorizing pi x out. Thank you. Pi x, 2r minus x. All right, I'm going to rub the working out so we can do the next bit. We probably don't need a lot of this, I hope. Okay. All right. Next one. Hence, which means even if you couldn't do I, you can still get 2 marks. Get used to that. I know a lot of the Year 12s were still, just before their trials, they were still not used to that. So start getting used to that now rather than next year. Hence or otherwise, show that it takes 3.5 times as long to fill the bowl to the point where x is 2/3r as it does to fill the bowl to the point where x is 1/3r. All right, what do you guys think you're going to do? Takes 3.5 times long to fill the bowl to a point where this. What are you going to do? Stop reading it too much. Trust me. Hence, sorry? No. Stop reading into it too much. Hence.
We use the dx over dt equation in I.
Right, and?
We sub in x, and we could rearrange it for r.
Yeah, that's it, of course. Hence, that means use it. X equals, sub it in. And you're hoping that when you do that, you can say one is 3.5 times as long as the other. So the rate that x, okay. You guys overkill these by reading into it too much. Remember, you're in advanced. If you're in standard math, yes, you've got to read the words. Because the words is all what standard math's about. Advanced, it's got nothing to do with that. It's about substituting, solving, simultaneous equations, factorizing. That's what advanced is about. Sub it in. Dx on dt equals k on pi x. Now, look, stop for those who know by now, the way I do this, if there's a fraction and there's another fraction, I don't write a fraction over a fraction. So I'm going to stop there. I'll restart. I write it like this. Okay, that's just me now. Divided by pi x. 2r minus x. And it's just a lot easier for me to read. Okay, divided by 2 pi r on 3. What's 2r take away 2 on 3? 2r on 3. Well, what's 2 take away 2/3? Should be 4 on 3. 4/3. And k times 3 times 3 is 9 on 2 times 4 is 8 pi r squared. We're okay with that? I'm just going to write at x equals 2r on 3. I think you guys know what I'm going to do now. At x equals r on 3, dx on dt equals k divided by pi r on 3 2r minus r on 3. 6 take away 1 is 5. 5r on 3. K times 9 on flip 5 pi r squared. All right, let's see what's happened. 9 and 5, 8. Hence, rather show it takes 3.5 times as long to fill the ball to the point where x equals. Yep. Give me a second. Can you just check the division of those two numbers? No. 9 and 8. Eight at 1.6 times. Where am I going wrong? Hence or otherwise show that it takes 3.5 times as long. Did I make a mistake anywhere? Yeah, I could have. That's 5r on 3, 5r squared, pi, 3 times 3 is 9. I'm happy with that. This one here is 4 on 3, 2 times 4 is 8, pi r squared, 3 is 9. Hence, rather, show that it takes 3.5 times as long to fill the bowl to the point where x is 2/3 as it does to fill the bowl. Isn't it filling a Henderson ball of radius r is initially until water is poured into it at a constant rate of k centimeters cubed per minute? Right. Filling the bowl. We're talking about the depth. This is the change in depth. We're finding time here. But this is the change in time, the change in height with respect to time. We're trying to work out 3 times as long to fill the bowl. We're trying to find the time it takes. So the other way around. It shouldn't be a big issue. Or does it change? If I did dt and dx, it would be it would be pi x, it would be this divided by k. This divided by k. I think I just realized what would have happened on what I just did time. Just one sec. No, 8 pi squared. Okay. No, the other way around. 8 on 1 pi squared. And 5 on 9. No, still not right. Where am I going wrong with this? Alright, let's have a quick look. I'll waste more time. I really want to finish this off. Question 5. Did I go wrong? You are going to find t, which we can't do right now because we're integrating. Then fair enough. I was trying to keep it year 11. Alright, you can't do double I just yet. Unfortunately. You're going to try to find t, time. So you've got to start from here, dt on dx, and we've got to integrate it, which is not this year. So that's unfortunate. But hey, at least we got to do some nice algebra. Don't worry. Next. We finished them all. 5c as well. Yep. Actually, that's a good one. That can be asked. DI. I know all of the U12s just looked at this and went, what? Let's hope you guys don't do that, because I can see Novak's face and he's going, what? Use this fact to show this. The only students that are able to execute this are those that keep telling themselves, what do I have? What do I need? How do I get there? Can anyone recognize how you're going to link the fact that you know? Obviously, this is a formula you're used to.
And then plus
What do you mean?
1. Because you have to do that formula, so
Look at it a bit more closer. Get close.
Sam,
Say it again.
alpha is tan n plus 1 theta, and beta is tan n theta.
Beta is tan n. No. Look at it a little bit more closer.
Move it to the other side.
Say it again.
Can you move 1 plus tan n to the other side?
Yeah. Okay. You said 1 plus 10 to the other side.
Yeah, the entire thing. I don't know.
I like it because that's how I would see it.
Yeah, like that.
Exactly right. That's the one you're meant to look at. And then from there, what would you say alpha is? From there, what would you say alpha is? Trust me, it's a lot easier. Just say it the first thing you see. Look. What would you say alpha is?
Alpha equals n.
Oh. Alpha is 10. How? 10 is 10. 10 is 10. Alpha is n theta. It's the angle. What is beta equal to?
N plus 1 theta.
That's it. Now you just sub it in. Tan n theta minus n plus 1 theta equals tan n theta minus tan n plus 1 theta over 1 plus tan n theta tan n plus 1 theta. The hardest thing would have, again, I think it was Shania that said it, We said, what do I like? Crunch. Look, you have this, you need this, and the biggest giveaway is the fact that it says 1 plus. Otherwise, you can see there's no cot. So that looks tricky to a lot of students. So don't look at the cot. Look at the things that are the same. To some, they would have said alpha is n plus 1 theta, because that looks the same. The problem is it contradicts this one here. So you're meant to use the positive case as much as you can. All right, and then obviously n theta minus n theta, what happens there? Or n theta minus n theta will cancel out. And then in this bracket, all you should have is negative 1 times theta, which is negative theta. So I'll scroll it down. We'll be left with negative tan negative theta equals, tan n theta minus tan n plus 1 theta over 1 plus tan. Now we know this bottom side, this denominator is going to move to the left-hand side, and then my left-hand side is going to move to the right-hand side. How come I know that? Because it tells me to move it to the left-hand side. So next line, I'll move this whole thing to the left, which will look like this. Equals tan n theta minus tan n plus 1 theta on tan negative theta. When I think of division of tan theta, I'm already thinking of cot. Right? Because we know 1 over tan is cot. But what's the problem? Again, I've got a problem. So 2 problems. This is cot negative theta, whereas I just want cot theta. This is n plus 1 minus n. This is n minus n plus 1. And this is a very, very, very small detail, which probably 99% of the state wouldn't know or wouldn't remember because it's not a big component. Tan and sine. Tan and sine are both odd functions. Are both odd functions. Cosine, or cos in other words, is an even function. What does that mean? That means if tan is an odd, what's tan of negative theta? It's the same as?
Negative tan theta.
Negative tan theta. Right? Negative f of x. So then that becomes this. Over negative tan theta. What happens to the negative for these two? Swaps them around, which is what you want. What's 1 over tan? Cot. And you're done. You just rewrite the answer now. Cot theta, tan n plus 1 theta minus tan n theta. One more time. The negative swaps these two around, because obviously imagine a negative in front of that and a negative in front of this. And then 1 on tan is cot. And that's the answer. So that's more detail. There's not many students across the state that will actually remember that. It's not emphasized very well. Cos and even, sine and tan are odds. Inverse sine, also an odd. Inverse tan, also an odd. Inverse cos is not. It's neither odd or even. It's got a 180-degree angle that it gets adjusted by. Okay. I think that's it for 2006. We're up to 2007. Let's start. 2007. 2007 HSC extension 1. All right. (2007) question 2A, 2B, 2C. We should be able to do all those. So just have a look at that. You should be able to do A, but that's just nothing. All right. Yes, yes, and yes. All right. How many marks? 4, 5, 8 marks. Go. Question 2, A, B, and C. Just take your time. For A, if you want a clue, can anyone tell me or tell everybody? T formula. For A, you've got to use your T formula and triangles. Hopefully it should work out. Your triangle look like this. You guys get out A?
I got it.
Yep, nice. Only up to C. You done more?
Okay, I didn't do it.
Emily, done? Which one? A, you got to use cos theta as adjacent over hypotenuse, and then sine theta as opposite over hypotenuse, and then when you simplify that math to the left hand side, it should end up with what letter? What letter? Should end up with T, because tan theta onto it is T. So try that now. Okay, time for me to start. 1 minus cos theta adjacent over hypotenuse divided by sine theta, opposite over hypotenuse. This would be a common denominator of 1 plus t squared. So it would look like this. 1 plus t squared minus 1 plus t squared on 1 plus t squared. Be careful, there's a negative there in front of the whole thing. Multiplied by, flip this fraction, and then 1 plus t, 1 minus 1 cancels. This becomes 2t squared. And then of course 2 and 2 cancels, square and t cancels, you end up with t, as you know. Like everything just got to cancel out. And you're going to end up with t, which equals to tan theta on 2 equals RHS. Something like that. And here it is again, right? Sketch the graph. Don't do I before double I. The way I taught this was always do your domain and range first. So technically you would have solved double I first. Double I looks like this. 1 to negative 1, 0, I think it's pi on 2, or is it pi on 4? No, it's pi on 2, to pi. And then that's your original. So from that, your range for this question becomes 0 less than or equal to y on 2. You have to divide by 2 because it's got to be monic. Less than or equal to pi. So the answer is 2 pi. And obviously the answer to the graph, so for answer I, there it is, negative 1 to 1. Your domain doesn't change. It's just it's from 0 to pi to 2 pi. Very easy 3 marks. So maybe once you've mastered this, you can tick that off and you go, okay, rates of change. Maybe that's a bit you want to work on. And last one. Any questions from A and B? From anyone? Maybe I went too fast. No. C, the polynomial has 0 at x equals 2. When p of x is divided by x plus 1, the remainder is 18. Find the values of a and b. I think we know this one is not going to be a sum of roots 1. It's only going to sub in. So when x is 2, p of 2 is 0. When x is negative 1, it's 18. So you get 0 equals to 4 plus 2a plus b, and 18 equals 1 minus a plus b. Solve simultaneously. What do we get? Someone tell me the answer for a and b. Anyone agree or disagree? Or we can check. Maybe not up to it yet. Yeah, looks right. Any questions? A, B, or C? All right. Emily, all good? Let's try the next block. So we just did 2. We're up to 4C. Yeah, let's do the replacement questions. So 1B, 6A, 4C. 1 star means hard, 2 stars means really hard. Which is good. So let's try it out. 1B, 4C, 6A. Okay. Let's go. It's hard for us, huh? 1B, oh yeah, okay. Absolute value with a little inequality. Doesn't look too bad, actually. All right, 2 marks. Good luck. Be careful when you're testing. Let me know when you've completed that, please. Huh? Of course, how would you know in your exam if it's correct? Tell me, what's your answer?
X is between 4 and 1.
Equal to, of course.
Equal to, yeah.
So 4 and 1. Anyone agree? Disagree? Not sure?
I got the same one.
Same answer?
Yeah.
All right, I can quickly test it now then. If it's 0... Ooh. Really? Wait, yeah, 0 doesn't work. Yeah, that's right. 0 shouldn't work. 2. 5 take away, yep, that looks good. 4. 4 is 8. 5 take away 8 is -3. Actually, that is 3. 3 is over 3 is 1. I'm pretty happy with that. Anyone not able to get that out and wants me to go through it? I guess to make it a little bit harder, you guys should remember if there was an x in the bottom, you have to make the denominator cannot equal to 0. So another solution would be x cannot equal to 0, and then you would have to add that into your testing. Otherwise, easy. Good work. Then, if there's no questions, we'll move on. The next one. I think, yeah, that looks right. 4C, yep, thought so. Exponential growth and decay. 5 marks. Good luck. They're stock standard. These ones here are stock standard. So whatever you see is what you'll get.
Sam, in my preliminary exam, they took out laws of change and everything.
Just so, including growth and decay.
Yeah.
So I'll be in year 12 for you. Yeah. Which is probably better than terms and comms in year 12.
Yeah.
I'm really responsible for these questions because we didn't have the APA and I did a top of AW. So the next time I'm studying that, and then I'm going to get a change
But it wasn't your fault, right?
and then we're all looking at that. I'm very tired. And then we're going off questions.
Yeah, yeah. I'm sure if they've done a mistake, they will take that into consideration. A biologist tested to see how much bacteria was present in a variety of food samples left in the classroom. It is known that after T hours, the number of bacteria present in a particular type of food is given by this. Don't forget N naught just means initial N. Don't let that confuse you. You could use the letter A if that's the way you like it. That's personally the way I prefer it. But N naught is just there to remind you that that's at time is 0. If initially, what does that mean for time? There was 16,000, which means N is equal to 16. Present after 2 hours, there were 35,000. So when T is 2, N is 35. You've got to find K. Before you can find K, what letter are you meant to find from the initially bit? Yeah, the N O or the A, that letter. You can make it the letter A. So first you're meant to find the number in front of E by subbing time is 0. Once you've done that, then you'll go and sub in your second set of conditions and you should be able to find K. Good luck. Let's see. All right, let me do I. So when N is equal to 16,000, you get something like this. E0 is 1, so you should just get A equals to 16,000. A or N naught, doesn't really matter, like I said. Then you have your new equation, which is now something like this. But it also tells you when time is 2, N is 35. So again, you're going to write 35,000 equals 16,000 E2K. And then I think by now, hopefully we know how to solve for K for this. We're going to divide by 16,000. Log both sides, divide by 2. Log both sides, divide by 2. So K should become, I think, log 35 on 16 on 2. It says corrected 2 dp. 0.39. Happy? How long, what letter? T. Would it take for the initial number of bacteria to triple in quantity? So initially there was 16. Yeah, 48. So pretty much find T when N is 48,000. Go and sub it back into the original, right here. But you already know what K is this time. So sub it into that. E 0.39 T. And solve for T. And it says, write your answer to the nearest minute. I'll wait and see what you guys do. All right, here we go. Double I, do the same thing, divide by 16,000. So you should get 3 equals E, 0.39t. Log both sides, divide by 0.39. What's your answer to the nearest minute? I got 2 hours and 48 minutes. Anyone got a different answer? Anyone get 49 minutes? 2 hours and 49 minutes? No, nobody got 2 hours and 49? How did you guys get 2 hours and 48? Sorry?
We plugged the original answer, I'm guessing.
I don't know why I can't hear you very well.
We didn't plug in 0.39.
I plugged in the exact answer as K, right? 0.3, which is not 0.39.
Yep.
Now, if you got 2 hours and 48 minutes, it's actually incorrect.
So if you are off by this one, you know,
Of course, you lose a mark. It says it to the nearest minute. Now, it doesn't mean 0.39 was right either. So, but the problem is this. So now, you guys got to understand something. The question's asking when will it triple in quantity. Now, if you use K as the exact answer, it should give you this. And again, this is pretty much the top students that I've had with Year 12s this year. The ones that they were constantly getting wrong are these worded style questions where they've got to round up or round down. They were still making those mistakes. That's pretty much the only mistakes when they walked in. Now look, if I did the exact answer, so exact K, I got an answer of 2 hours, 48 minutes, 25 seconds, and blah, 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 right? If you guys want to check it out, you can. You'll get something like that. If you did rounded K, you would get 2 hours, 49 minutes, 1 second, and blah, 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 blah. Now to what you guys know, of course, the way you've been taught from like junior high school, is obviously if this is less than 30 seconds, you always round down. And that's it. You've always just been taught it like that because it hasn't been applied math. It's been theoretical. You've done it with like trig, which is theory-based. It's not part of applications. But if you understand what I'm about to say now, you'll learn to just be extra careful. Now the exact K is the right way. So we have to use the exact value of K, that's the right way. But then some students go, but then when we use rounded, I got the right answer. When I use exact, I didn't get the right answer. How come? The reason being is this exact number, this one right here, is the point when the bacteria would triple. This is the point when the bacteria would triple. So if I round down, would you say the bacteria has tripled? No, because it's still got another 25 seconds for it to triple. So you've got to round up. This one here, 2 hours and 49 minutes and 1 second, blah, blah, blah. If you've done it like that, which is rounded K, the only reason why it worked is because obviously you just know, oh yeah, at 1 you're meant to round down. But that's not the right logic. Because obviously you've used a rounded answer. So the only reason why this worked is because by coincidence, it was at 1, so you're going to round down, which just gives you the answer that you need. The right way to do it is this rounded down would not be enough to get you the triple value that you want. So you have to actually round it up. So the answer we're looking for is 2 hours and 49 minutes. Yeah, I know. I know you feel, because the 12
Sam,
Yes.
could you say during the 48th minute?
During, but it doesn't say that, right? It doesn't say during which minute. If it did, that's actually another question. It might ask during which minute. You will say during the 48th minute. You're right. That's a different question. During the 48th minute, but it just says give your answer to the nearest minute. So you will say 2 hours and 49 minutes. All right. Triple I. What will be the rate of increase? Rate of increase. What do we do? You don't do that. What's the word? Rate.
Derivative.
Derivative. Not used to it yet? You gotta get used to it. Rate. When you see rate, differentiate. What is the rate of increase of the bacteria after 8 hours? So when time is 8, find me the rate. So what are you going to do? We're going to start again back to our original. Where is it? There it is. N equals 16,000. E, we'll just leave K as K for now. And then, all right, what is the derivative of this? What's dN on dt? Someone tell me their answer. What's the rate? What's the derivative of 16,000?
T 16,000 EKT, right?
Did you say T?
Oh, no, K in front.
Okay. K 16,000 EKT. Differentiate the KT, which is K, because you differentiate with respect to time. So it's just K, and then you keep the exponential the same. Does that make sense? Of course, it just says time is 8. You already know what K is. Good luck. That's it. How many marks? 1 mark. Oh yeah, because it's easy. I guess express your answers to the nearest 100. Again, you would get it wrong, potentially, if you use 0.39. I'm going to use our K value as K times 16,000 times E K times 8. I got to the nearest 100. What will be the rate of increase of the bacteria after 8 hours? 143,400. 143,400. Round up. We agree? Emily, did you get that as well? Let's see what happens at 0.39, just for everyone's curiosity. Times 16,000 times E, 0.39 times 8. At 0.39, it would give you 141,300. You can see how far off you are. But don't use rounded answers. I think that's clear by now. All right. Any questions? Please, rate, differentiate. That's it. You gotta memorize that. You see the word rate, you think of derivatives now. All right. 6A star, we still haven't done. Question 5. Okay, you guys can't integrate, so don't worry about the integral sign. Just forget that. Can someone tell me how to simplify this? Simplify this. Sine 3x cos x. Think of your formulas. It was the only one that I allowed you. I said I allow you to look at your formula sheet for them. Sine, cos multiplied together. Okay? Go look at your formula sheets, go online, type in extension 1, HSE formula sheet if you want. Find the one you would use for this. Tell me.
Is it the sine A cos B formula?
That's the one. Sine A cos B. Can you tell me what it is equal to?
Half sine A plus B plus sine A minus B.
Done. So it looks really hard, but I mean, like even the integral bit looks hard to a lot of students. But the idea is when you see a sine and cos multiplied, you're going to break up into just sines or just coses. So the answer to this is just half 3 plus 1, 3 minus 1. For those who already know how to integrate, you know how easy this is. The integral of sine is just cos. Integral of sine is just cos, so very easy 3 marks. But that's year 12. So the harder bit is the year 11 bit. No one to use the formula. The integration bit, piece of cake. All good. I just thought I'll do that since I saw that. That's vectors, that's next year. The diagram shows the graph as a dotted curve. We are. All right. We did say this. Let's read. The diagram shows the graph of y equals f of x represented as a dotted curve. Yep, that makes sense. The points 1 and 1, 1 and 1 right there, and negative 1 and negative 1 and 1, negative 1 and 1. No, I think negative 1 and negative 1. Don't worry, they did a typo there. Let's hope that doesn't happen in your HSC, which it has. It has happened. But anyway, negative 1 and negative 1 lie on y equals f of x, and it has x-intercepts of negative 1, yes, 1, yes, and 3, and 3. Wait, what is happening here? Okay, I'm going to start again. The diagram shows a graph of y represented as a dotted curve. This is a dotted curve, okay? The points 1 and 1, 1 and 1, negative 1 and 1 lie on f of x. It has x-intercepts of negative 1, 1, and 3, and a y-intercept of 3. Okay, that's completely off. It's completely off. So don't stress, I'll fix it up right now. Look, I think I can see what's happened. They've shifted the axis a bit, and they forgot to actually. They've done the question right. They've just shifted the axis a bit too much to the right. That's okay. We can fix that up. It was meant to look like this. It has x-intercepts of negative 1, 1, and forget this. I think it's easy just to say forget that. That's okay. And as x approaches negative infinity, y is approaching 2. No, it's not. It's approaching negative infinity. Yeah, they completely stuffed this up. All right, you got to forget all that. You guys have been super confused. On the same diagram, draw the graph of this. Okay, we're going to draw the graph of y equals 1 on f of x. And then I'll try to, from what they've written, draw the graph that they wanted you to use. This one here is really easy. Again, we know that this is going to be hyperbolic in nature. There it is. And same thing with this side. There it is. So that goes on forever, negative infinity. 1 over 1 is still 1. And then sad is happy. There it is. This one's the important one. Negative 3. If I flip that, it's negative a third. So somewhere here. And you've got to put negative a third in. Otherwise, that was really easy. So now, let's do what they're asking. Unless I'm missing something. But I don't think so. But anyway, let's see. That's fine for everyone? Yeah, because I've already been giving you the asymptotes. Alright. Now, the points 1 and 1 and negative 1 and 1 lie on f of x. It has x-intercepts of negative 1, at 1 and at 3. Has a y-intercept at 3. Okay, so it's probably going to do that. And also as x is approaching negative infinity, y is approaching positive 2. As x is approaching negative infinity, y is approaching 2. Does that work? Just like that. That's the only way. Has to start up here, bounce. Okay, so you can see two things there that just happened. The original one I would have drawn without this condition would have been this. We agree with that? Without that condition. Then all of a sudden, with that condition, the problem is if down here it's going to negative infinity. So as x is approaching negative infinity, as x approaches negative, my y values are approaching negative infinity as well. But the question is telling me, as x is approaching negative infinity, your y value has to be approaching 2. So approaching 2 is here. That's an asymptote. It's not going to go through 2. So that means as x approaches negative infinity, it's going to approach 2, so it looks like this. Now, I can't cut through this, because what happens if I cut through it? That's okay, cut. But then I'm meant to have a y-intercept up here. But I'm going to have an x-intercept. Otherwise, you might go, oh, then come up. But then that means you have another x-intercept. So you can see I can't cut through. So if you can't cut through, what would be the other option of not cutting through? Think of all the graphs you've learnt in polynomials. Those bounce. Those cutting through, bouncing, and then the squiggly.
Squiggly, yeah.
All right. So we're going to bounce, intercept, that could be an answer. Make sense? Now we're going to draw the inverse of that. 1 on f of x. The reciprocal, I shouldn't say inverse, because now that you guys learn inverse, there's a difference between the two. So inverses are flipping about y equals to x, reciprocal is flipping. All right, let's do it. Okay, so these ones are easy. Asymptote there, asymptote there, asymptote there. We're okay with that? At 2, it's no longer 2. Where is it now? At half, right? Because we're going to do 1 over 2. So your asymptote E is now at a half. Still with me? And then we've done everything right. Red curve. So here we go. That's that one. This is happy, sad. I don't know how far down I've gone, so we're just going to go over it. Because if it was 1 over negative 2, it'll be negative half, so just go up a little bit. That's perfect. 1 over a sad is a happy, and then it's at 3, so it should be at a third. Be careful, that's a half, so a third is somewhere here. And then otherwise it's very easy. There it is, and approach this asymptote. There it is. It's really bad little kink, but we can fix that up. There it is. Happy with that? This bit, which gets everybody, because they're like, I don't know what to do with this, this asymptote here. Well, slow it down. What's 1 over a very small number? 1 over very small, very large. It's going to start up here. 1 over a little bit larger, a little bit smaller. 1 over a little bit larger, a little bit smaller, and so on. What happens as this gets closer and closer to 2? This guy will get closer and closer to? No, to half. That's why we've got our orange curve there. It gets closer and closer to half. It won't ever go to a third. Why? Because this never goes to 3. You can see that logic? This red curve will never go to 3, so it will never go to a third, let's say. So the black answer will be the answer we're looking for. Oof. But yeah, that diagram had nothing to do with what they've written, but that's alright, we fixed it up. Alright. Anything else? Nope, they're back. Let's have a look at another one. How are we going for time? Ah, alright. We'll do one more. We'll find one more. 3b. That's it, whatever it is. We'll do one more. And for those who want to stay back and go through advanced work, you can do that as well. I don't mind. 3b. 3b. Find vertical. Oh, there it is. Find vertical and horizontal asymptotes of this hyperbola. Straight away, what can x not equal to?
4.
And does anyone think they
Why
know?
can't equal 1?
Say it again.
Why can't equal 1?
How'd you do it?
Because if you had if you let y equals to 1, you'd have x minus x. The x cancels.
Yes, I agree. Is there any other way you know to do it? No. Okay, that's fine. For your hyperbolas, you must. The requirement was you must numerator be 1 power less than the denominator. So numerator must be 1 power smaller than denominator. So therefore what you do is you technically meant to use polynomial division, but I'll tell you the cheat. You divide by the highest denominator. So your highest power of your denominator is, or your highest pronumeral is x. So you divide everything by x. Rings a bell to some of you? And then that becomes 1 minus 2 on x on 1 minus 4 on x. The idea is as x is approaching infinity, this becomes 0, this becomes 0. The answer is 1 on 1. So y cannot equal to 1. Tricky. Hence, sketch the graph of this. If x can't equal to 4 and y can't equal to 1, there it is. And then obviously to graph it is very easy. You need to find your x and y intercepts, which I've completely ignored. But it looks like our y intercept is positive half. And then x intercept looks like it's going to be at 2. So try that out. And try double A at own time as well. Just keep in mind x cannot equal to 4 is one of your solutions. Forget the inequality, make it an equal sign. Just do it normally. Don't do x minus 4 squared. That's not our method on both sides. That's probably the way you guys got it taught at school. It's just not what we do. Yeah. Normal. All right, like I said, if you want these exams, message me. I will send them to you. If you've got questions,